Here we have some examples of organic naming. I'm also going to draw the structures so you can see kind of what's going on with everything. But let's start with this first one. The very first thing you need to do is determine how many carbons there are. And in this particular case, there's one carbon, so we're going to start with the prefix meth. Because we have just one carbon, the prefix for one carbon is meth. Now I know one carbon isn't going to make any sort of bond to another type of carbon or another carbon, so we're going to use the ending "and," indicating single bonds. And then this group here is an alcohol. Again, if you look at your list, when we have alcohols, these end with OH. We end the name with OL. This is methanol. We draw methanol very easily. It looks like this. We've been drawing a lot of organic compounds, so you should be able to put that together. Here, in our next one, we have two carbons, and our prefix for two carbons is F. So F. How are those two carbons attached to each other? Well, let's draw it out so we can see. The first carbon has two hydrogens attached. Then it is attached to another carbon. Because of the octet rule, we know there needs to be a double bond in here. We get another H and an OH here. All right? So now we can talk about the type of bond between two carbons. That's where this middle section comes in. When it's a double bond, we use En. So ethene, and we have another alcohol, that's ol, ethanol. And it looks like this. Down here, again, we have one carbon, all right? So we're working with meth. Again, because there's only one carbon, we're gonna use an. And then OOH. This is a carboxylic acid, and we indicate that in our naming by writing oic acid. This is methanoic acid. And the way that it's drawn is, it looks like this, okay? Let's move on to these three, all right? They're gonna get progressively more difficult, but again, you can see this OOH group, which again means it's a carboxylic acid. We have two carbons, so our prefix is F. If you're unsure what sort of bond goes between those two carbons, draw it. In this particular case, we get our CH3. So we know it has to be a single bond to the other carbon. COOH. There we go. All right. So how do we end this type of compound? Well, there's a single bond between the carbons, and it's oic acid. Sorry about the confusion in here, but ethanoic acid. There we go. Here, this is a little more difficult. All right. These compounds are esters. Esters are responsible for fruit smells and things like that. So here, we'll draw it out first, and then we'll name it. We start with CH3. Then we're connected to another C. And you can tell that whenever you have two oxygens next to each other, we're getting this carbon double bonded to one and single bonded to another. And that single bond here branches off into another CH3. In this particular compound, the way that we name esters is we look at the group out here. And if you look at your reference list of names, this little group right here, this CH3 group, we call a methyl group. So this is our methyl group right here. Now our main chain here, we have two carbons. Our prefix F comes into play when we have two carbons. There's a single bond between them, methane, and because we have an ester here, the endings are oate. This is methyl ethanoate. There we go. Down here, this one's kind of long, all right? And I'm gonna draw this with organic drawing. It's gonna look a little bit complicated, but it's actually not that bad. It makes life a little easier for us. Here, to start this off, we have 1, 2, 3, 4, 5. This is a 4 here. 6 of them. So we have 6 carbons. So I'm gonna draw 2, 3, 4, 5, 6. I have my 6 carbons there. And we know on that 6th carbon, we're going to have a double bond to an O and a single bond to another O, all right? And that O is then going to be connected to two more carbons. Each point here represents a carbon. And I've only drawn a single line between them because that indicates single bonds. So let's talk about this, all right? Again, we have our ester because we have our O or COO group here in the middle, COO group here in the middle, connected to two chunks of carbons. Well, we know this chunk on the end has two carbons in it. And our prefix for that, when we talk about a two-carbon chunk, is an ethyl group. So we have an ethyl group on the end, and if we come back over here, we count up the carbons. 1 plus 4 plus 1 gives us 6. Our prefix for 6 is hex. We have single bonds between all the carbons. It becomes hexane-O8 because we have our ester. So these are 6 examples of organic drawings, and in the next video, I'll have 4 more examples so we can go into a little bit more detail.